Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Yet another video in which I am going to discuss about the secret of 10x faster calculations. Now you must be wondering how so many people they can calculate in mind, how they can add the big numbers, subtract them and also multiply the big numbers, that is 2 digit, 3 digit, 4 digit numbers mentally. So there is no rocket science behind this. You just need to learn the basics, and basics is what most of the students lack. So practice these basics which I am going to discuss in this particular video, and this is going to form a very good base for your preparation of school exams or whether you are preparing for any placement exam. This is going to prove really useful. Vedic maths. We all talk about Vedic maths, and so many of us have learned also. But watching the tricks is only one thing. Practicing those and putting them into practice, that is applying them to solve some of the questions which are based on simplifications, in which you have to deal with numbers smartly, and that's what is the most important thing in mental maths. So today I'm going to discuss the use of 9's and 10's complement in the use in the maybe the calculations. I'm going to take up subtraction also. I'm going to discuss about multiplication also, and you will see how the base of Vedic maths works for us in mental mathematics, right? So watch the entire video. You're going to learn something which will help you in higher order calculations. We have put all these short tricks, you may call them short tricks, in the form of an ebook of short tricks which carries a very nominal cost. And if you are ready for that, and you want to excel in mental maths and perform all those calculations just like the mathematicians and the champions do, then this ebook of short tricks is for you. And what more, you get the reasoning puzzle course free of cost along with the purchase of the ebook of short tricks. How to procure that? Here we have written the WhatsApp number 9896369963. You can find this number in the description box here, and for the complete ebook of short tricks and the reasoning course combo, you can send me a message on WhatsApp. I'll tell you how to get a copy of that particular combo. Let's see the first application now. Subtraction. Now mental addition, mental subtraction, these two operations are the basic operations, and if you are good in mental addition and subtraction, so many problems of multiplication and division become easy. And that is why I keep on stressing on the need of working on these basic operations. So watch, I am going to use some of the Vedic maths tricks to subtract numbers from base numbers, that is numbers which have zeros at the end, like 10, 100, 1000, 10,000 and so on. So when you have to subtract the numbers from the base quantities, you don't have to do anything. You don't have to write the numbers one below the other and then perform the subtraction. You just have to be aware of the 9's complement and the 10's complement. I'll show you how. Let's take some examples. The first example I'm going to take up is a very easy one so that you understand the method. Let's do 100, which is a base number, minus 37. Now see, here we have two zeros and here you have two digits which are to be subtracted. And whenever this is the case, the calculation is very easy. You can just watch and tell the answer. How do we do this? Now this 37 is the only thing I am going to concentrate on. I am not going to concentrate on 100 because I know it is a base number and it carries two zeros, which is equal to the number of digits here. So what am I going to do? The 37, I will take the 9's complement of 3. 9's complement means I will have to subtract 3 from 9 and I will have to subtract the last digit from 10. This is also called all from 9, last from 10. So what will happen if you subtract 3 from 9? You get 6. And what will happen if you subtract the last digit 7 from 10? 10 minus 7 is 3. So you get your answer. You don't have to write them one below the other. This is the use of 9's complement and the 10's complement. Now let's study this in a detailed manner. Let's have one more question where I am trying to subtract, say, 1418. So I know there are 3 zeros and there are 3 digits which are to be subtracted. So it becomes easy for me to handle this. I just have to take the 9's complement. Keep on taking 9's complement. For the last digit, you have to take the 10's complement. Right? So 9's complement of 4, 9 minus 4 is 5. 9's complement of 1, 9 minus 1 is 8. And 10's complement of 8, that is 2. 582 is your difference. Now you may argue here that I am taking equal number of zeros and equal number of digits here. Even if the number of digits here are less than the number of zeros, this method still works. Let's take an example where we have more number of zeros like 10,000 and we are subtracting any, say, random number from this, say 752. Okay. Now you can see there are 4 zeros, but there are only 3 digits which are to be subtracted. Now these are the things which you should understand and you should be aware of, so that you do not commit very silly mistakes in handling these type of calculations. Now equating the number of digits with the number of zeros in the base number is very important. So here you have 3 digits and 4 zeros. So what will I do? Before applying all from 9 and last from 10, I am going to equate them by putting a 0 here, and that doesn't make a difference to the calculation, right? 752 remains 752 even if you prefix a 0 here. So the answer will be now obtained by applying the 9's complement of all the digits except the last one. For the last one you have to take the 10's complement, right? So 9 minus 0 is 9. 9 minus 7 is 2, 9 minus 5 is 4 and 10 minus 2 is 8, which gives me my answer for the question. Now you can pick up the calculators and check once whether we are doing it correctly or not, and if you are convinced, we can do one more calculation where we have like 6 zeros and we are subtracting a 4-digit number from this number. So let's take the number to be, say, 2097. Let's take any random number. So I know that the number of digits here are 4, but the number of zeros are 6. So I have to equate the number of digits first. So before I take the 9's and the 10's complements, what will I do? I will prefix 2 zeros with 2097 so that this number now contains the digits which are equal to the number of zeros. Okay. And now take the 9's complement of all the digits. For the last digit you have to take the 10's complement. So 9 minus 0 is 9, 9 minus 0 is 9, 9 minus 2 is 7, 9 minus 0 is 9, 9 minus 9 is 0 and 10 minus 7 is 3, thereby giving you the answer for this particular subtraction problem. So subtraction from base numbers, this is one of the very basic Vedic maths trick, and I took up this all from 9 and last from 10 trick for this video because I wanted to get you into multiplication of numbers. So let's see how the same use of 9's and 10's complement can help you in cracking problems of multiplication, especially when you are multiplying numbers by 9's. So multiplication by 9's. It is not that 9's and 10's complement can be used only for multiplication by 9's. You can actually do it for random numbers also. Obviously you have to work on it and you have to extend the method and extrapolate it on some special numbers, right? So let's see the first example. In the first example, I am going to take up, say, 73 which contains 2 digits and I am going to multiply this by 99, right? So the number of digits here are 2 and the number of 9's here are 2, and so the problem becomes very, very easy for me. So I just wanted to check how many digits are here and how many 9's are here. So since they are equal, now I can forget this 99. I just have to consider this 73 to get my answer. Now the first step here is to reduce this number 73 by 1. So I'll write all the steps. 73 will be reduced by 1. This will be your first part of the answer. And for the second part, you will have to do what? You will have to do all from 9 and last from 10 for the number 73. So 9 minus 7 and 10 minus 3. This is what you need to do in the second part of your answer. So 9 minus 7, I'll write all the steps. See, 9 minus 7 and 10 minus 3. So what will be the answer? 73 minus 1 is 72. 9 minus 7 is 2 and 10 minus 3 is 7. Now you can check the answer. 73 times 99 is 7227. Likewise, you can increase the number of digits. Let's have a 4-digit number which is to be multiplied by 4 9's. So let's take 2608 and multiply that by 9999. So the method doesn't change because the number of 9's here and the number of digits here are same. So what did I tell you? You have to reduce this number by 1. So that becomes 2607. And now keep on taking the 9's complement of all the digits of this number. But for the last digit, you have to take the 10's complement. So 9 minus 2, 7. 9 minus 6, 3. 9 minus 0, 9. And 10 minus 8, 2. And that gives us the answer for this problem. Don't you think it will take you only an observation to get to the answer? Not even a pen and paper required to solve these type of questions? And yes, it works like this. Now let's complicate the problem for ourselves. The next type of question which I am going to take up is what will happen if the number of digits are unequal. So here we have 4, here we have 4, 2, 2. That's so simple, right? Now let's have the number of digits here less than the number of 9's. Okay, so let's do 48, which is a 2-digit number, times 999, which is a 3-digit number. Does the method change? Very slightly. How? We can still equate the number of digits here with the number of 9's here by just prefixing a 0. So this becomes 048, and now we can apply the same method. Reduce the first number by 1 just like we did here. 2608 became 2607. 048 is 48, right? So this reduces to 47, and now I will take the same rule. All from 9, last from 10. That is, take the 9's complement of all the digits, don't forget the 0 here, and 10's complement of the last digit, and you will have your answer. 9 minus 0 is 9, 9 minus 4 is 5, and 10 minus 8 is 2. Here you have your answer. 48 times 999 is 47952. So you can check it once. Take a look at this and we will solve one more question. Then we will move on to the third case. Let's take a question where we have 3 digits in the first number here, 682, and we are trying to multiply this by 99999. You can take as many 9's you want. You will still get the answer orally. Okay, 682. Now 3 digits here, right? And how many 9's? 5 9's. So how many zeros to be prefixed here? We have to prefix 2 zeros. So 00682. Now this is the number I will consider for multiplication by 99999. So if you reduce 682 by 1, you are going to get 681, right? And now take the 9's complement of all the digits and the 10's complement of the last digit. 9 minus 0, 9. 9 minus 0, 9. 9 minus 6, 3. 9 minus 8, 1. And 10 minus 2, 8. Now see, it's a big 8-digit number, 681999318, which happens to be the correct answer for this product. Right. So we still have one more thing, right? What will happen if the number of 9's are less than the number of digits in the first number? And that's where the most important part of the video is. So watch now what happens when multiplication by 9's is to be done for numbers having greater number of digits than the number of 9's. Let's take an example here in which we are going to try to do 384. This is a 3-digit number and I need to multiply this by 99. Now so many of the students will say it's easier, it's very easy, like 99 can be written as 100 minus 1. So we can multiply this by 100 and this by 1 and then subtract the 2, right? Perhaps the method is easier than that. Let's see what are the steps involved here. So as you can see that here we have 2 digits, right? 2 9's. So what will I do here for 384 is I will separate it out like this, having 2 digits on the right of the slash. Okay, now that is the first step you need to take up. Now I will apply all from 9 and last from 10, that is 9's complement of this digit and 10's complement of this digit. What will happen here? 9 minus 8 is 1 and 10 minus 4 is 6. Now 16 becomes the last part of my answer. That means your answer for this product is going to end in 16. Now what about the first part? Now remember the rule. The number 384, I'll take up the number 384 here. I'll have to subtract something from this, okay? And subtract what? The remaining number here which I did not consider till now. 84 has already been considered, okay? I obtained 16. The number which I did not consider is 3. Its successor, that means its next number, is 4, and I will subtract 4 from the complete number 384. So what will I get? I'll get 380, right? And believe it or not, friends, just write 380 here and check. 38016, is that the product of 384 and 99? You will be surprised by the accuracy of the result. Let's see another one where I'll be trying to multiply, say 6543, a 4-digit number, by 999. So number of digits here are more than the number of 9's. So I'll separate it like this: 6543 times 999, right? Now I have to take 9's complement of all digits of 5 and 4 rather, and 10's complement of 3, which will give me my last part of the answer. So 9 minus 5, 4. 9 minus 4, 5. And 10 minus 3, 7. So this becomes the second part of my answer. And what about the first part? The number 6543. I have to subtract something. What? Subtract 1 more than the remaining part of the number, 7, from this. So 43 minus 7 is 36, right? So 6536, and so my answer for the question will be 6536457. Little bit of practice and you will get used to this process. It is not difficult at all. Just applying it for 20-30 questions and you will feel comfortable with the method. Let's complicate the problem. Finally, one more question. Let's take 56584 and I want to multiply that by 999 again. Okay, let's take 999 again. So 999 means 3 9's, and 3 9's means I have to separate out 3 digits from 56584. So I'll write 56584. Now let's take the 9's complement of 58 and 10's complement of 4. So I'll write the answer here. Okay, 9 minus 5 is 4, 9 minus 8 is 1, and 10 minus 4 is 6. So my answer is going to end in 416. Now the number 56584, I'll have to subtract something from this, right? Subtract what? 1 more than the remaining number. So 57 is to be subtracted from this. So I don't think 565 will get affected. It is just 84 minus 57. So this is 7 and 2, 27, right? So 56527 is the remaining part of my answer, which I write here, 56527. And now pick up the calculators, check 56584 times 999. Is it this big number? You will be really surprised. So friends, Vedic maths is wonderful. The if you start studying Vedic maths, forming a good base of your calculations, especially the students at junior level, students who are studying in class 3, 4, 5, they should start doing these basic tricks right from that level, and parents and mentors are responsible for this. You need to put them into practice. You need to put your children into such things very early in life, so that they build up that aptitude which is required to have 10x faster calculation speed. And all these videos will surely help you out, and if you watch these videos, do practice these concepts, and I'm sure your speed of calculations will increase manifold. So friends, if you like this video of secret of 10x faster calculations, the use of 9's and 10's complements of Vedic maths, it's a concept in Vedic maths in subtraction and multiplication, then do share it with all your friends and all your WhatsApp groups. That will be a great help, and don't forget to subscribe the channel if you have not done till now, and along with the subscription you need to click the bell shaped icon so that you keep on getting all the notifications of the future uploads. Thanks for watching this video, and all the best for your practice.